Hello, good morning students. How are you? I hope everybody is fine. Today we are going to study about the electric dipole. So, what is a dipole? Electric dipole two equal and opposite charges separated by a small distance. These are the two equal charges and separated by a small distance. This is called the electric dipole. This is called the electric dipole. The directions of the dipole is from negative to positive. You know the example of dipole, NaCl, ordinary salt, NaCl. Plus 1 charge, minus 1 charge. Sodium donates 1 electrons, becomes plus 1. Chlorine accepts 1 electron, becomes minus 1. So, in this way, dipole is formed, yes, and that is why NaCl. This is the one examples of the dipole. This distance is 2a. The midpoint of the two charges is called the center of the dipole, and this midpoint is, if it is 2a, it is A and ES. So now let us see some qualitative ideas about the electric dipole. The first, the total charge on the electric dipole is 0. There is no electric field. There is no net charge. Net charge is 0, minus q and plus q, 0. It does not mean that electric field is not there. Electric field is there. If two charges are separated by some distance, then there will be a electric field on the dipole. So it is written here, since the charge q and minus q are separated by some distance, the electric fields due to them when added do not exactly cancel out. So electric field will be there. And see the third point. However, at distance much larger than the separations of the two charges forming a dipole, the fields due to q and minus q nearly cancel out. Means this distance is the r. Suppose this distance is much larger than this dipole, distance of the dipole, then electric field will get cancel out due to these two charges. Yes. So at a larger distance, the electric field due to a dipole therefore falls off at the large distance faster than like 1 upon r square. We have seen this. There is a one single charge is there. The electric field is inversely proportional to the r square. We have seen the formula k q r square. So this is a constant, so E is inversely proportional to the r square. This is in case of single charges, but here is what two charges are there, dipole is here. So in case of dipole, electric field falls off inversely proportional to the r cube, not r square. So these are the some qualitative ideas, and these qualitative ideas are borne out by the explicit calculations. Let us say now, we will take first case. This charge is plus q, this is minus q, this distance is 2a, this is the center of the dipole, its distance is a, the distance is a. Now, in first case, we are going to find out the electric field on the axial point. This is the axis and we'll find out electric field at some area on the axial field. This is the P. So now here at point P, so due to the positive charge, you know that positive charge, it's what? Radially outwards. Its direction is what? Radially outwards. So here its directions will be in this directions due to plus Q. And now due to negative charges, we know that radially, so it is inward. It goes to the negative charge. So its direction here is in this direction. है ना? Positive charge is there, negative charge is there. So from positive to negative. Positive direction go radially outwards, and in this one directions will be radially inwards. So it goes radially inwards, radially outwards. So net electric field, we are getting two electric fields. First due to this plus Q, another one is what? Due to minus Q. And electric field is a vector quantity. So total electric field E1 plus E due to plus Q, E due to minus Q. So we will find out first electric field due to plus Q. So electric field due to plus Q. We know the formula. Electric field is the formula 1 upon 4 pi epsilon naught Q upon R square. So here plus charge is there, plus Q 4 pi epsilon naught. So we have to find out the distance now. We have to find out the distance. So from this plus Q to up to this P. So this is the center of the distance. This is what? From center of the dipole, and P distance is R. So what is this distance? Total distance minus this distance, you will get this distance. Once again, total distance from P to the midpoint of the two charges, and this is a plus charge. So distance is total R minus A and square. We get this distance. Since it is a unit vectors, so this is a vector quantity, P is a point, so unit vectors we are writing like this was cap, P cap. Second, electric field due to minus Q. So minus Q 4 pi epsilon naught. Now the distance from this distance and this distance at this point. So this is what's total up to this. This is R, है ना? R, and this is what? A. So total distance what? R plus A square. Unit vectors. Now we know that if two vectors are in opposite directions, and we add this, we get like this one. Suppose this one vector is magnitude is 7, another vector in the directions is magnitude is 2. So as per the triangle law, first vector's head and second vector's tail. Second vector's tail. So 7 minus 2. Result is what? 5. Here we apply the triangle law, we will also get the same thing. E net is equal to E due to plus Q plus E due to minus Q. We write here E net is equal to due to the plus q 4 pi epsilon naught r minus a square. Now, since this point is near to the plus q, the electric field is more. So, this vector's magnitude is more and this vector's magnitude is less, because this point is not near from this point P. So, minus q 4 pi epsilon naught r plus a square. Well, take the common q is the common 4 pi epsilon naught, and we get here 1 upon r minus a square minus r plus a square. Q 4 pi epsilon naught, will take the LCM, r minus a square r plus a square whole square, cross multiplication, r plus a whole square minus r minus a whole square. Q 4 pi epsilon naught, we will open this bracket, r square plus 2ra plus a square minus r square minus 2ra plus a square divided by, will also, this is a whole square, so we can take it r minus a and r minus a, twice we can take it since it is a whole square. Same case here, r plus a and r plus a. Here we will open the bracket here, so q 4 pi epsilon naught r square plus 2ra plus a square minus r square plus minus minus plus 2ra minus plus minus a square divided by, now check it here, we know the formula, here we know the formula, a plus b and a minus b is equal to a square minus b square. Same case will do it, a minus b, a plus b, a minus a plus b. So, r minus a, r plus a, again r minus a, r plus a. So, we can write here q 4 pi epsilon naught, r square cancel out, a square cancel, remain yes what, 4 r a divided by, है ना, again the formula a plus b, a minus b, a square minus b square से r minus a, r plus b, so r square minus a square, again same r square minus a square. So please note down this. So now we further solve this one. Here electric field, net electric field is equal to q upon 4 pi epsilon naught 4 ar divided by, now again same quantity is there, so we can say here whole square, r square minus a square 2. Okay, so now this r is very very larger than 2a. So when r is 2a, है ना, so we can neglect this a. So here q 4 pi epsilon naught 4 a r. So here this quantity, if it is very larger than 2a, na, this is the a, 2a, and this is your point is like this was r. So this distance compared to this distance is very greater than this one. So it is just like 20,000 and 2 rupees. So we neglect this time. In this case, we neglect this. We take only 20,000. Like this one, we can also do, yes, we can neglect this one. So r square. So q 4 pi epsilon naught 4 a r raised to power 4, है ना. This is the formula used, yes. A raised to m raised to n. So formula get a raised to mn, like this one. r2 2. So r2 into 2 r4. So we get r4, yes. So q 4 pi epsilon naught, and this r and 1 r cancel, remain 3 years. So 4a upon r cube. So net electric field 4aq upon 4 pi epsilon naught r cube. This is the net electric field on the dipole when your point P is on the axial point. So it is not completed yet. This formula we have derived, but it is not completed yet. So when we will study dipole moment, so we will rewrite this formula in that way, yes. So students, I hope you liked this video. In next video, we will see the another point, that is a point on the equatorial plane. Now we will see what electric field we get on the equatorial plane, and then we will compare both the electric fields on the axial point and electric field on the equatorial point, and we will see, will the differentiate the electric fields between them too. And also we will also study the dipole moment, and when we study dipole moment, then we will rewrite both the equations. Okay, so students, I hope you like this video. Thank you very much for watching this video. Bye.